Okay, this is video project 2 about invisibility cloaks by Shelby Stoner. So from a physics perspective, a true invisibility cloak would be one that bends light around an object from all directions in order to be completely invisible. And a rather simple way that scientists have been accomplishing this is through cameras to record and project images of what's behind an object onto the object's surface, which then in turn makes it seem like the object isn't even there. An example of this is this photo right here, a coat using the optical camouflage. The real key, though, to creating a true invisibility cloak involves metamaterials, which are metal dielectric composites engineered on an extremely small scale. And the composite structure acts as an array of artificial atoms. So this enables an electromagnetic radiation to pass freely around the object. Then the metamaterial guides the light around the object, and this creates the illusion that the object isn't there at all. So, in today's time, there is a company called Hyperstealth Biotechnology Corporation that has seen recent success with their invisibility technology. They do have a patented prototype called Quantum Stealth, which is actually being developed primarily for military purposes, kind of like how we had discussed in class. And they want to use this in order to hide military personnel and equipment like tanks and jets in combat. But they not only want to hide or distort objects from onlookers, but it could even conceal these objects from infrared or ultraviolet images. And so this is all done through lenticular lens. So lenticular lens are formed in sheets where the ridges are made up of an outward curving lens, and the rows of these lenses refract light according to the viewing angle. They also found a way to arrange the layers of these lenticular lenses in order to create dead spots at certain distances behind the material. So then that way, when it's viewed from the front, the object behind the material is not visible, but the background is. So this is what creates that illusion of invisibility, which is kind of what we're seeing in this little graphic on the right-hand side. And right now, the prototype may not offer complete invisibility, but it's still very, very good at distorting objects well enough so that it's very, very difficult to discern the details of what is behind the invisibility cloak per se. However, right now, the biggest challenge facing the development of practical cloaking devices is the actual ability to cloak a wide range of wavelengths. So that kind of goes back to what we were discussing in class, using microwaves in order to produce invisibility as well.